Welcome to the training of power system protection. Before proceeding to the discussion about the power system protection, let's start and understand the modern power system. How modern power system look like. So the power system is essentially consisting of generation, transmission, distribution and utilization levels. So we have 4 levels. So you can see here, this is a simplified diagram that is showing different components of our power system. So for the power we want to use, we need to generate it first, and you can see here that the generating power plant is available here, and the generation could be solar, wind, thermal, nuclear or hydel. So there are different type of generating sources. So normally these power plants are located or situated near to the source, or near to where the fossil fuel or where the energy source is available. So for example, the coal power plant you will find near to the coal mines. So it's an ideal to install the coal power plant near to the mine, and then voltage can be, or power can be generated, and then it can transmit it to the load centers. Because if you install it, the power plant near to the load center, then you need to take out all the coal, put it into the trucks or in the train, and then transmit it to the remote location, which is very expensive. So the need arises to transmit the power to the longer distances. So if you want to transmit the power at the longer distance, obviously if you transmit it at the low voltages, the losses will be high, and it is governed by a very simple equation, and that's called as P is equal to V into I. So we know that the power is equal to voltage into current. So if you want to transmit the, for example, 1 megawatt power, so if you increase the voltage, then at the same voltage you can supply the same power at the reduced current. So we would like to reduce the current, and we would like to increase the voltage in the transmission level, because if the current is less, then the line losses will be reduced. So the losses in the line are I square, or losses in terms of the heat loss, and the voltage drop across the longer line, that's equal to I into Z. So here you can see if the I is less, then again the voltage drop across the long line will be decreased as well. So it means that the voltage regulation of the line that's operating at the lesser voltages is easier as compared to the line that's operating at the higher voltages, higher currents. So in order to reduce the line losses, we are transmitting the power at the higher voltages. So you can see here that we are generation is taking place normally at 11 or 22 kVs, then it is being step up, and you can see this is a generating stations, or this transformer is called as generating transformer. They are stepping the generating voltage up to the transmission level. So there are different type of transmission levels in different countries. Some countries has 132 kV voltage levels, someone has 115. So depending upon their practices, 230 kV, 380 or 345 kV, 500 kV, and for the longer distances even 765 kV voltage levels are being used. So when this transmission is done for the long distance, then again the voltage is stepped down, and then it is voltage is stepped down from the extra high voltage or high voltage to medium voltage levels. The transmission voltage is then reduced to the distribution voltages, medium voltage, and then from medium voltage the voltage is further distributed to the utilization voltages, that is 400 volts or 110 volts depending upon the country you belong. So we are calling the grid station or substation. Basically the reason behind is that in the start all the power plants used to have a yard where you can find the transformers. That's job is to step the voltages up. So the main generating station used to be called as the substation or the main station, and then again the small yard that is responsible to stepping the voltage up used to call as substation. So we used to have station or generating station, and substation name is coming from this by this way. Next you can see when the time evolved, the micro SCADA developed, and then all the signals, all the status commands, controls, measurements are from the load center or generating stations are being transmitted to a centralized location, and that's called as, for example, national control center or regional control centers. And again the smart metering is now being injected in the network, so the smart meters can detect the flow of power. So with the same smart meter you can even import or export from your house. So there come the concept of microgrid and you can see smart metering. Then we have domestic level power generation nowadays. So as I told you, now in the modern power system you can install a small generating source like solar at your roof, and you can even export this power through the smart metering to the utility. Then we have complex systems. Now in the start the different regions in a country were not connected. Now more and more regions are being connected together, and that's basically creating a complex system, a very complex system to monitor and control. So there are the advantages and disadvantages of this integration, or it's connecting all the equipments together. First disadvantage is that the fault MVA, total fault MVA, is basically increasing, and another thing is that cascade tripping can also shed the whole system if it's all connected together. The advantages are obviously the power is now available. You can switch on especially the cheaper source available in your network, and you can see even one source is for example, or one generation is stripped, another generation is available to take the load, and immediately without any interruption the system can work very nicely. So here you can see this another representation. As I told you that the generation is taking place at 12 kV almost, or some places 22 kVs. So beyond this it's become uneconomical to manufacture a transformer, to manufacture a generator, because generator is a rotating part and insulation level will be higher, so generation is kept at these medium voltage levels. Then we have step up transformer, and then you can see we have 400 kV line, and it is called as a transmission line. And then we have step down transformer, then we have 13 kV distribution medium voltage level, and then we have low voltage levels, and it is connected to these houses to supply the power. So this is how a modern power system look like. Thank you very much.